Hi everyone. In this video, we're going to look at a few examples of how we can write repetitive code without using a for loop. Now, the reason we're making this video is that we've seen a lot of students in class using for loops to write code that doesn't actually require the use of a for loop. And generally, this is not a good thing to do because NumPy and baby pandas have much quicker ways of writing or performing operations over and over again without needing to use a for loop. So in a lot of these cases, using a for loop is making your code much slower and also more difficult to debug. So let's look at a few of these examples of tasks that we can do without using a for loop. Okay, so the first thing that we can do without using a for loop is creating an array of numbers that are sort of in increasing or decreasing order, spaced out by some amount. And of course, here I'm talking about np.arange. So the way that np.arange works is I can give it a starting position and an ending position, and by default, it'll count up by 1, starting at my starting position and going until right before my ending position. So np.arange 1, 21 gives me an array of the numbers 1 through 20, the integers. From 1 through 20. If I don't give it 2 arguments and I just give it 1, it'll start from 0. And there are a bunch of ways that I could play around with it by counting by something other than 1 and counting downwards, so on and so forth. But generally, this is what np.arange does. It'll create an array with spaced out numbers in it. Now you could technically do this with a for loop, but it would be a really, really bad idea to do so. Let me just show you what this might look like. So often we start by creating a blank array. So here I'm going to create an empty array called numbers. And I might say something like for I in np.arange 1, 21, take my numbers array and to the very end, add on the value I. And so when I run this code, the result is going to be the same as using np.arange 1, 21. But you should definitely not do it this way, right? The way that this code works is it's saying for every element of this array, I'm going to run this code. But all this code is doing is recreating this array that we already have. So having to run this indented code 20 times is kind of a waste of time for the computer. And it's just better to just go straight to np.arange 1, 21. Or whatever it is the range that you're looking for, just use np.arange and you'll be good to go. Okay, so that's one example of when not to use a for loop. Another example of when not to use a for loop is when you want to perform some sort of operation on every element of an array or of a series. And remember, series are columns of data frames. So let's suppose we have this data frame containing, the salaries of various NBA players, and this should say array/data frame methods. And let's suppose I want to compute the number of players whose salaries were above $11 million. Now, we actually looked at how to do this in lecture 5 or lecture 6, way before we learned about for loops, right? The way to do this would be to say, hey, well, let's first get all the rows where the salary is above 11 million. So by writing nba.getSalary greater than 11, it's comparing each of these players' salaries to the number 11. If it's greater than 11, I'll have a true. Less than 11, I'll have a false. Then I can use Boolean indexing to say, okay, give me all of those rows. So now I have a data frame. I can zoom out a little more. Now I have a data frame with only the players making over $11 million. You can see I have 61 rows in this data frame. If I write dot shape and then square brackets 0, that'll give me, that'll give me the number of rows in this data frame, which as a result is the number of players with the salary over $11 million. So I was able to get that result without needing to go to for loops. Again, I could do this with a for loop, and I'll show you how you could if you really wanted to. But again, it's really not a good idea to do this. right? I could say num players is equal to 0, and then I could say for salary in NBA.get salary, if the player's salary is greater than 11, take my number of players and to it add the value 1. So I have this like running counter of the number of players whose salary is greater than 11 million. And if it's true that their salary is greater than 11 million, add 1 to this counter. Now this actually doesn't work at all. You need to use np.array here. But nevertheless, that should be num players. This does work. And if I ask for num players, I'll get 61, which is the same result I saw over here. So it works, but this is far more complicated than using a simple data frame query followed by a dot shape. And the same kind of principle applies if you want to do something to every element of an array, right? If you have an array and you want to multiply every element in it by 2, you can just write the name of that array times 2, right? Operations occur element-wise to NumPy arrays. So just keep that in mind. Okay, what if we want to sample repeatedly from an array? Okay, so let's just suppose I want to repeatedly randomly select one of 3 options: rock, paper, or scissors. Can't spell today. Well, we know that np.random.choice, if we give it an array and no other arguments, what it will do is just randomly pick one of the elements in that array. So every time I run this, I'll get a randomly selected element from rock, paper, scissors, and each of the elements has the same probability of being selected. Now, if I wanted to pick 50 of these moves, right, or so pick a random move 50 times, I could do this in a for loop. But that would, again, not be a great idea. Instead, what we should do is provide a second argument to np.random.choice. And when I do that, it will internally somehow select an element from this array randomly 50 times. And the way that it does it internally is just way faster than if we were to write a for loop on our own. Okay, so again, this is probably the most important instance of this. This came up in Lab 5 in the fall 21 iteration of the course. You don't need a for loop to repeatedly sample from an array. Just provide a second argument to np.random.choice. Now, just to refresh your memory, what if I wanted to determine the proportion of these moves that were equal to paper or equal to rock or something? Well, what I can do, I can take this array and compare each value in this array to the string paper. Okay, so when I run this, it's going to give me 50 randomly selected moves, and it's going to say, okay, was that move equal to paper? Now, some of them were falses, some of them are trues. Note that this array here does not correspond to this array here because I called np.random.choice again. So when I ran this cell, I got 50 new flips, or new selections. And then what I can do is use np.count non-zero, which will take an array of trues and falses and tell me the number of those elements that were true. np.sum would actually also work in this case because mathematically, trues are counted as ones and falses are counted as zeros. But I'll use np.count non-zero because that's what you'll see most often in the homeworks. Okay, and a proportion is a number divided by the total number of attempts. So in this case, if I had 18 papers, my proportion of papers would be 18 out of 50 or 0.36. Now again, when I run this, it's going to generate 50 new selections from this array. So the proportion will be slightly different, but you get the idea. No for loops were needed to come up with this proportion. Okay. Now, this is not directly related to what we're talking about, but I think it's important for me to mention it. np.random.multinomial also allows us to, simulate some sort of random experiment, but the way that it works is a little different than how np.random.choice works. So np.random.choice works by taking in an array and returning randomly selected elements from that array. That's not how np.random.multinomial works. How it works is we give it a categorical distribution, so we give it an array of probabilities, and it simulates the act of selecting elements from that categorical distribution. Let me illustrate that for you. So suppose we wanted to select 50 random elements from rock, paper, scissors. And let's suppose that all three of these options, rock, paper, scissors, are all equally likely, meaning that they have a probability of 1/3 of being selected. Well, then all I need to do is run this one piece of code. This is saying 50 times select an element from a categorical distribution where all three options are equally likely. And in this case, the first number we could interpret as being the number of rocks, the second number we could interpret as being the number of papers, and the third number we can interpret as being the number of scissors. So every time I run this, I'll just get a number of rocks, a number of papers, and a number of scissors. Okay, so it's working slightly differently than np.random.choice, which would show me a specific sequence of rocks, papers, and scissors. Here it's just giving me Here it's just giving me a number of them, but it's kind of worked the same way. Okay, cool. So at this point, you may be wondering, okay, I can do a lot of things without a for loop. When do I actually need a for loop? And so to boil it down to sort of one statement, it's this. We use a for loop to perform an experiment multiple times. Now, one experiment might be, say, flipping a coin 50 times and determining the number of heads. To do just this part, flip a coin 50 times and figure out the number of heads, no for loop is needed, right? And I'll show you how to do this, but you don't need a for loop for that. The for loop would come in when we want to run this experiment 100,000 times, let's say. So we'd have a for loop that repeats, the process of flipping a coin 50 times 100,000 times. Okay? And this is the primary reason you will use a for loop in this class. You will rarely, if ever, need to use a for loop for any other reason than this. So let's walk through what this might look like. So I'm going to define a function that will perform this experiment once. So one time, it'll flip a coin 50 times and figure out the number of heads. So I might say, okay, my flips, well, I'll use np.random.choice here, but as you saw, I could use np.random.multinomial. I'll say heads and tails, and I'll say, okay, pick an element from this array randomly 50 times. Now remember, np.random.choice by default samples with the replacement. It wouldn't really make sense to sample without replacement here because then we could only flip the coin twice. Okay, and so what I want to do is use np.count non-zero and say, okay, count the number of times that my flips were equal to heads. And so every time I run this, it'll give me the number of heads in 50 simulated coin flips. So this is one experiment. Okay, and again, each time I run it, it's a random result. It's going to be something somewhat close to 25, probably. Okay, great. So now suppose I want to run this function 100,000 times. That's where the for loop comes in. So this is a pattern that you're going to see a lot in this class. You're going to start off with an empty array, and you're going to say, okay, for I in np.arange 100,000. So there we go. I'm going to say, let's first call this function one simulation. So this is going to give me a number of heads in 50 coin flips. And then I'll say, well, using np.append, take whatever is already in my results array and add this new result to it. There shouldn't be an S there. There we go. And so now when I run this, it's going to call my one simulation function 100,000 times and each time determine a number of heads. So if I, give me a second here, ask for the results array, I'm going to have an array of 100,000 elements in it. Okay, each one of these corresponds to a number of heads in 50 coin flips. One thing I want to point out though is how quickly it was that this cell ran, right? We can do it again. You'll see that it runs in about 4 seconds or so, right? And what it's doing is 100,000 times repeating this code. And this code is flipping a coin 50 times. So how many virtual coins are being flipped total? Well, it's 100,000 times 50, which is 5 million. So in about 4 seconds, it's able to flip 5 million virtual coins, which is pretty cool. Now again, and so here's a empirical distribution of number of heads in each of these coin flips, centered around 25, as you would, guess. Again, you could have done this with a for loop, like this act of, doing one experiment of flipping the coin 50 times, repeating that 100,000 times. It's possible to do that with a for loop, but here we would actually need what's called a nested for loop, or a for loop inside of a for loop. I'll show you how you can do it just so that you're aware of it, but you will almost never have to use a nested for loop in this class. So if you find yourself writing code that involves a for loop inside of a for loop, you should stop and ask yourself, are you certain what it is that you're doing? And if not, of course, ask for help. Okay, let me just show you what a nested for loop looks like in general. So I might say something like for I in np.a range 1, 6, for j in np.a range 1, 6. I'm just going to write this code first, and then I'll show you what it does. J equals I times j. There we go. So what I now have is sort of my 5 by 5 times tables. So how this is working is it's saying, okay, for I in the array 1, 2, 3, 4, 5, for j in the array 1, 2, 3, 4, 5, run this code. So you'll see one line here corresponding to every combination of elements in this array and elements in this array. So since there are 5 numbers here and 5 numbers here, this code is run 25 times, once for each of those combinations. And so it starts off with setting I equal to 1 because that's the first element of this array. And so for I is equal to 1, it runs this for loop. And so that's why we have 1 times 1, 1 times 2, 1 times 3, 1 times 4, and 1 times 5, because see, this I is coming first. Then, after it's done running this for loop for I is 1, then it says, okay, well now the next value of I in this array is 2. So it runs this for loop under the assumption that I is 2. And then that's why you see 2 times 1, 2 times 2, 2 times 3, and so on and so forth. And it does that for every combination of I and j. So this is a nested for loop. But remember, our example was flipping a coin 50 times, counting the number of heads, and doing that 100,000 times. So how would we do that with a nested for loop? Well, let's see. We might again start by creating a empty array in which we will store our numbers of heads. And I might say something like for repetition in np.a range 100,000. One thing I'll point out is that we often put I here, but it doesn't really matter what variable you put here as long as it makes sense in the context. It's not that Python does something special if you use I there. For each of these 100,000 repetitions, what I'm going to say is, well, I need to keep track of the number of heads in each of these repetitions, so I'm going to create a variable for that, and I'm going to start off by setting it to 0. So now I need to say for, let's just say, j in np.a range 50, now I need to actually flip the coin. So I can say flip is np.random.choice heads and tails. So this is flip a coin just once. Notice there's no comma 50 here. We're just flipping the coin once, right? Because we're illustrating how we would do this with a nested for loop. And I might say, okay, if my flip is equal to heads, then take my sort of counter number heads and add 1 to it. So if I see a heads in this flip, well, the 0 is then going to become a 1. And then the next time I see a heads, this 1 is going to become a 2, and so on and so forth. Okay, I'm almost there. All I need to do now is after I've flipped this coin 50 times, I need to say, okay, I flipped it 50 times. I have a number of heads in those 50 flips. Let's keep track of it in this results array. So I'm going to do something like this. And so I'll run this. But what I want to point out to you is that this takes way longer than the first method that we used that only had one for loop, right? That finished in about 4 seconds. And if you don't believe me, you can go back and watch the video or rewind in the video and you'll see that it finished really quickly. I've been talking for probably about 15 seconds or so, and this is still not done. It'll finish in, I'm guessing, around 30 or so seconds. But you can see that this is taking way longer than our method that, only had this outer for loop. This inner for loop we replaced by just putting comma 50 here. Okay, and you can see it's still running. Again, it'll finish at some point, but it's taking way too long. And so we really don't want to use nested for loops in this class. Okay, and so it's finished running, but it took far longer than the other method. Okay, just to show you again, the other method that I'm referring to is this right here. This code is all you need to redo that very last nested for loop. And it finished so quick, right? So that's really the point of all of this, right? Don't use a for loop because it's just far slower for a lot of these tasks that involve randomness and arrays and series as compared to methods that are built into NumPy and Baby Pandas. Okay, so that's it for this video. Hopefully this clarified some misconceptions, and if you're still a little unclear about when to use a for loop and when not to use a for loop, just post on CampusWire and we'll take a look. Thanks for watching.